Clayton Community Centre is the first of its kind, designed to be net zero energy ready to meet the top step of the BC Energy Step Code. The City of Surrey opted to pursue Passive House certification, making it Canada's largest passive house facility to date.
The City of Surrey is really proud that we are setting a precedent with this project. Even ahead of Step Code coming in, we were basically hitting the highest step. Recreation centers tend to be used for very long hours and very intensely, so the energy use is quite high.
There was a real appeal in having a building that may be less complicated to operate. They wanted to, I think, shift away from some of the focus on the active and more, as Passive House suggests, the passive components.
The Clayton Community Centre features many unique components that work passively, the most significant of which is the building envelope.
Try to think of it in the simplest way possible. So it doesn't want to have any thermal bridging. It wants to have very clean, simple details.
The air vapor moisture barrier is adhered to the exterior sheathing. This critical membrane in the assembly is carefully installed throughout every transition to prevent air and water leakage.
That membrane is the air tightness for the building.
Another key component is the insulation.
The design required 6 inches of semi-rigid mineral wool to be installed with intermittent thermal clips.
Fiberglass thermal clips penetrate through the insulation. Because of the shallow footings, supporting the exterior masonry cladding required a secondary base of concrete outboard of the slab edge, separated with 6 inches of insulation. Glazing is carefully balanced to favor areas in need of solar gain.
They want to reduce the amount of glazing in general to about 30%. So your window to wall ratio would be about 30% window and more like 70% wall.
The second level acts as an overhang to create solar shading for the glazing in the lower level. Canopies protruding from the roof use thermal-resistant pads to protect metal supports from thermal bridging.
We need to keep it strong. It needs to be metal, but we also don't want that thermal bridge. So a 1-inch thermal-resistant pad basically was coupled right in line with the insulation. Windows
and doors are pushed out to align with the insulation. Fiberglass angles are used to support the windowsills. A curtain wall system implements an EPDM gasket to separate the interior frame from the glazing and pressure plate on the exterior. The glazing is triple pane. The roof system is a compact assembly. Similar to the wall, an air and vapor barrier is installed above the decking to provide continuity of air and vapor control. Mechanical stands, access ladders, and anchors that normally contribute to thermal transmittance are given thermal breaks aligned with the insulation.
Quite early on in the design process, we realized that there are very high numbers of people in the building from early in the morning to the end of the day that are generating a lot of heat.
The building uses 6 ventilation systems, which are split up by function areas to meet the demands of the occupants.
The mechanical rooms are all internal, they're all inside. We want to keep that distance between the HRV and the occupied space short.
Working with Integral, our mechanical engineer, we ran a series of tests, bringing in motorized windows that brought in natural ventilation.
The building automation system will decide, when to open the windows, but we all know that people like to have control over their own environment. And so there's an open-close button on there so the users can't come and close the windows.
Much of these systems rely on natural ventilation, reducing the need for mechanical cooling to roughly 5% of the year.
In all of our buildings, we have problems with entrances. And so you get this cold air blowing into the atrium. So what we did was we located a revolving door at the main entrance.
The revolving door can be fixed into place, acting as a conventional sliding door so that people can pass straight through.
The City of Surrey is really proud that we are setting a precedent with this project, even ahead of Step Code coming in. It's one of the largest passive house projects that are on the books in maybe North America.
I think that Passive House is invisible, and I actually think that's really wonderful. It felt good to be there, it felt good to stay longer. So not only does it have all the program offerings that you want, and it creates the spatial qualities that make you want to stay, the comfort that comes out of it is quite profound, and it's all kind of invisible.